Hello, I'm Mr. French. I'm coming to you from my classroom in Mount Pleasant, Utah, and this is topic 3.6 of the AP Calculus AP Classroom curriculum, higher order derivatives. So the idea here is that if a function, f of x, has a derivative, f prime of x, that's also a function, well, if we called it g of x, well, we could find the derivative of that function, g prime of x. But the derivative of that function is really the second derivative of my original function. And we could clearly apply this logic to additional derivatives. Remember, since we do have two different ways of signifying a derivative, we'll have two different ways of indicating a higher order derivative. If we use the prime notation, f double prime would indicate the second derivative. If I use the dy dx notation, here you can see that our derivative, or second derivative, looks like this: d2y over dx squared, d squared y over dx squared. Let's just take a quick example of that. If I want to find the second derivative of my function f of x equals x cubed minus x, well, first I have to find the first derivative. And by the power rule, we would get 3x squared minus 1. And then my second derivative would be the derivative of 3x squared minus 1, which becomes just 6x. And we can take a look at how those functions are related. If my second derivative is 6x, well, that's just a line through the origin. That's the green line here. The blue line is my original function, x cubed minus x. And the red line is my first derivative, 3x squared minus 1, the parabola. Take a look at these and see if you can find some relationships between these three different curves and how they might be related. We know that one is the derivative of the next, and then the third is the derivative of the second. But why do they have the shapes that they do? We'll discuss this further in a later lesson, but I do want to plant the seed for that. So there we have our second derivative for the function x cubed minus x. Our third derivative, again, would be the 3 apostrophes, so f triple prime of x, and then our third derivative using the dy dx notation, d cubed y over dx cubed. Once we go beyond the third derivative, we no longer use the apostrophes in the prime notation, but we do continue to use the same notation in the dy dx scenario. Okay, so let's look back at our original example where f of x equals x cubed minus x. We know that the second derivative turned out to be 6x. Well, then the third derivative would be the derivative of 6x, which is just the slope of the line y equals 6x, or 6. And if we look at the relationships here, we can see that purple line is our new derivative at y equals 6. Once again, take a look at these four graphs, the original function and its first three derivatives, and think about why they take the shapes that they do. Look at maximums and minimums and zeros, and think about those relationships. In the next video, we'll go over some examples of higher order derivatives.